Hi friends, welcome to the CAIIB session. Today we'll be handling the CAIIB part of correlation and regression. So before that, just remember this: whenever any obstacle arises, you change your direction to reach your goal. You do not change your decision to go get there. This is presently required in the present situation, right? Then you can download this Adda 24/7 app for your better future and get all the entrance exams details. Okay. Also, you can get this use this Y432 code to avail discount of 77% discount. And today and tomorrow, we are running a special session, this CIB ka Mahapack. Okay. So this Mahapack is basically what are you getting is students can avail plus 3 months extra validity on CIB and JAIIB. Okay, at no extra cost. So avail 77% discount also, as well as you can get this Mahapack also. So let's start with today's session. Today we'll be handling correlation case study. See here, I'm specific to the exam. I don't give you much knowledge. I don't give you every knowledge of all the full correlation in the world. No, only related to CIB. That's what is needed, right? So the problem is, yesterday we had done the theory of correlation. Today we'll be handling the case study. So for the following data, find the best fit line. So best fit line means what? It is called the regression line. Compute the standard error of estimate. So we have to find the standard error also. Find an approximate prediction interval for the dependent variable y when x equals to 44 with 95% confidence level. Now what is 95%? We have already discussed it yesterday. Okay, 3 levels were there: 68, 95, 99, right? So in exam also you will be given this x and y, all the values of x and y. Okay, so what we have to do is we have to find out the line which fits this x and y. Okay, remember yesterday what I taught you? I taught you that time series also. In time series, we had said that we have to make x as 0, right? But here it's not like that. Okay, so let's start. What you have to do is first plot x and y. X and y. Okay, x and y means this. Now you'll say in exam, is it possible to do all these things? But in exam, the other point is on the numbers, how many items are there? 3 plus 3, 6 plus 1, 7. So big numbers won't be given. You will be given roughly 4 to 5 max. Generally 4. Okay. So the table becomes small in exam. Okay. So what you have to do is you have to go through a strict format. I've given you this format also in yesterday's lecture. So please join today's lecture. Okay. So this x and y, it's given over here. What we have to do is we have to go in a strict fashion only. We don't have to change our way over here. Okay. Our goal is very simple. What we have to do is find x square, find y square, then find xy. Okay. First step, x square, y square, xy. Now, how is this possible? You have a calci in your exams. Calci is allowed. So find the squares. Generally, there are 4 items required in the exam. There means in the question also, generally 4 are only given. So find the square of x, find the square of y, find xy. Okay, done. Now I have 7 items. So I found out for all. Then what you do? You total them. See here, in exam also, you prepare a rough table like this, fast on the paper. Okay. Then find the total of this: x total, y total, x square total, y square total, and xy total. Now you'll say, why do we find out all these things, x square, y square, xy? Because you'll see in the next slide, we have the formulae. And that formulae require all of them. Once you are through with this x, y, x square, y square, and xy, mind well, 90% of your problem is solved. Remaining only simple part, just inputting the values remains. Okay. So now we have found out this total. What you do? Find the average also immediately. Average means what? 333 divided by how many numbers? 7. So answer comes out to be 47.57. Total upon n. Similarly for y, 269 upon 7. Similarly x square, 6189. Where did I get this 6789? here. I found out the x square of all x's, then added them. Similarly, this 10594 y square, same y square, and then find out. Yesterday I told you something that in x, if there is odd number of elements and even number of elements, right? Even then double it, but that is for time series only. It's not at all for correlation. Okay, correlation is very simple. Okay, so done. X square total, a y square total, xy total, average, x average, y average, x square average, y square average, and xy average also. Okay, xy means what? Just multiply these two, get the total, and divide it by number of elements in, that is 7. Okay, in exam it will be roughly 4. Okay, now once you have found out this, now look at this. The problem becomes much easier. Now we have to remember only the formulae. So what are the formulae? Okay, first is variance. You have to find out. I'll again say we have to go as per the steps 1, 2, 3, 4, 5, 6, 7. I had given you 11 steps yesterday. Same will be followed over here. Okay, so variance we have to find out. How to find out the variance? Variance formula is very simple. X square upon n, summation x square upon n. Now where do you get the summation x square upon n? See this, x square summation x square upon n, right? So this is the answer. So summation x square upon n minus x bar square. Mean means x bar. We write it x bar also. X bar square. Now where do I get this x bar? See this x bar 47.57. What do you mean by mean? Mean is what? It's just the total of all the elements and divided by number of elements, right? So that's what we are doing it over here. So it becomes x bar is 47.57. How did it come? Total them, divide by number of elements. So it becomes x square upon summation x square upon n minus x bar square. Okay, we have both the values of this. So the answer comes out over here is 49.67. In exam, what I would suggest is you try this using your calci. Okay, because in exam you will have to solve it yourself. But again, I'm telling you a caveat for exams, such big numbers won't be given. 7, 8, no, only 4 or 5, because they don't want to test your calculation skills. They want to test your knowledge. Okay, so now you have found out x square upon n, summation x square upon n minus x bar the whole square. Okay, variance of x done. Once you find out the variance, find out the standard deviation. What is the formula for standard deviation? It is the square root of variance, always. Right? So 49's square root is 7. Now variance x is done. Similarly, you have to do what? Variance y. How to do variance y? Same formula. X summation x square upon n. So here it will be summation y square upon n. Okay. Now you'll say where is summation y square upon n? See this, y square is over here. Total upon n 1513, right? So summation y square upon n. I got it. What do you mean by summation? Summation. I'm telling you always. Summation is to summation y square upon n. So this total upon n, right? This total upon n. Okay. So what have I got now? So minus mean y whole square means y bar the whole square, right? So equals to, again you get, then we have once you have got the variance, what you do is find the standard deviation. Standard deviation again what? The square root of this. So it comes out to me, say this, it was 26. Yeah, so standard deviation is what now? Square root of this. So square root of this is what? 26.779, roughly 5.1. You have a calc, you can do it. Okay. Now you have found out the variance of x. Now you have found out the variance of y. Now you find out the variance of xy. That variance of xy is here. Why did we take all this x square, y square, xy? Because your variance of x, your variance of y is nothing difference. Right? Variance is same, variance of xy is same. Covariance it is called. Okay. As we get frets or we get difficulty in remembering the formula. So always remember there is only one formula. I'll give you one formula slide at the end also. So remember, x square upon n for x, y square upon n for y. So xy will be, instead of square, it will be, we want the power of 2 only. So it will be xy. Same thing. See, I repeat again. Summation y square, summation xy upon n. So where do I get this value of summation xy upon n? See here, I have done the total. Summation xy upon n I have taken it. So summation xy upon n I have got it. So it is summation xy upon n minus what? See this. It is y bar. So here it is xy. So it will be x bar y bar. Simple, right? It. For variance x it was x bar square. For variance y bar square. So covariance it will be, when you have single, you have the square of that guy. You have single y, you have square of that guy. But you have, when you have double, you'll have only one because the power is maximum required is 2 only. Power maximum is 2. So x bar y bar. Where is x bar y bar? Just now we have got it over here. And also we have in this table x bar, this x bar y bar. Okay, 47 and 38. So now you have all the values. What you do is you just input it and you get the covariance of this xy. So that is what 36.45. Forget this further number. 36.45. Okay. Now you don't find the standard deviation of xy. Remember. Now you'll say, okay, standard deviation variance x, standard deviation x, variance y, standard deviation y, covariance xy, standard deviation xy. No. This again, then the point is, for covariance what? So for covariance we have coefficient of correlation. Remember, these are the only steps by which you should go. Okay. So coefficient of correlation is what? Yesterday also we have seen in a lecture. So what is that? Covariance of xy, okay, divided by psi x psi y, standard deviation of x and standard deviation of y. Now, where is this covariance of xy? Just now we have found out. Where is the standard deviation of x? It's just now we have found out. Square root of variance of x. Standard deviation of y. Square root of variance of y. Just now we have got this. Okay. So you have all the values. Once you have all the values, then just input the values and you get the R, correlation. Now, what is this correlation? Coefficient of correlation. Coefficient of correlation gives you the strength. Strength means takat, we call it, right? How much strength is there in these numbers with relation to one another? If I draw a line, how much can they be near to each other? Okay, so that is the strength given. So coefficient of correlation here, it's 0.9991. So it's roughly equal to 1. So that's why these elements are linearly related, means 1:1 ratio they have. Okay, now we have found out R also. But what is asked for us? For this, find the approximate, this complete this best fitting line is asked, right? Best fitting line means over here, y equals to a plus bx. Yesterday also we saw this. Y equals to a plus bx. This is the line we require. Now, what is this form of that line called? Slope intercept form. You might have studied it in 9th, 10th or 11th somewhere, right? 9th, 10th generally we have studied this. So y equals to a plus bx. Now what we have to do? Just we have to find the values of a and b. Once you find a and b, y and x are variables. They remain as it is. Okay. So how to find out a and b? First find out b. What is the formula for b? Same formula over here. Same formula. Say this. Except these two are there. Standard deviation x, standard deviation y. We don't do this. What we do? Covariance of xy upon standard deviation of x the whole square. Now, which is near to x? Take x only. Because you'll get confused in exam. Do I have to take standard deviation of x or standard deviation of y? But what is standard deviation of x the whole square? That is variance, right? Square root of variance is standard deviation. So square of standard deviation will be variance. Simple. Square of standard deviation is variance. So if I write, instead of writing standard deviation of x, what do I write? I can write it variance of x over here, right? So what is b? Covariance of x upon variance of x. Covariance of xy upon variance of x. Okay. So that is b. Now, do you have both the values? Yes. Covariance xy, we are already having it over here. Variance of x, we are already having it over here, 49.67. Okay. So I can find out b now. Just input the values and I get this value of 0.733. I'm not doing this calculations over here because we are at a CIB level. CIB level, if I go on showing you all the calculations like the school guys, we'll go mad. Okay. And the portion won't be completed. So that's why B you have found out now. Now I've got B. Now what I have to find out? A. How to find out A? I know B now. Instead of X and Y, I'll put some constant values. So what are the constant values? This X bar and Y bar. If I input this X bar and Y bar instead of this X and Y, what are X bar and Y bar? Means these are the means. If I input the means, these are the numbers basically. So what will we have now? See this over here. It will be number over here, Y bar, some number. What is that number? This one, 38.56. Then A I don't know. Plus B again, I've just now found out, right? 0.73. And then X bar again, instead of X, I'll put X bar, 47.57. Now if I input all the values, then what will I get? Number, unknown constant, number, and number. I'll multiply these two now, right? Get the answer and then take it to the other side. So A equals to what? Mean of Y means Y bar minus B into X bar, right? This I am taking it on the other side. So mean of Y into minus B into mean of X. All the numbers I am having it now. I'll input these values and what do I get? I get A. Now this A, see, remember this A and B are constant. Once I get this constant anyhow, the same constant will remain throughout the line. You put any values then, okay? So now I've got it A and B, both I've got it. Again, I'll come back to this equation. So what is this equation now? Y equals to 3.64 plus 0.73 into X. That's what I've got. So that's what is the required question. Find the following best fit line. Best fit line means you have to find out this only. Y equals to A plus BX, values of A and B. Okay. So next question is what? Compute the standard error. So what is the formula for standard error? Standard error, yesterday we had seen it. What is standard error? That you can find directly write down as standard error equals to square root of summation, this brackets, y square minus A into summation y minus B into summation xy. Okay, the whole upon n minus 2. Now there is also another formula for standard error that is called as standard deviation upon root of n. Okay, but don't use this over here. Okay, how to remember this formula? You'll say it's so difficult to remember this formula. No, it's easy. How? I'll tell you. What you do is take, you know, this y equals to A plus bx. Take this A plus bx on the other side. So what it becomes? Y minus A minus bx, right? Y minus A minus bx. Got it? Just multiply everywhere with y. So what does it become? Y square minus ay minus a b xy. Y square minus ay minus b xy. Got it? First, I'll take everything on the other side and then multiply by y. Okay. So the answer now is y square minus ay minus b xy. What is this? Y square minus ay minus b xy. Only summation is attached. What's the difference? So it's easy to remember this formula using this standard error for the standard error. Okay. So square root of, remember, y square minus a summation y minus b summation xy. But you're having all the values now, the whole upon n minus 2, right? You're having all the values now. Y summation a y square, I'm having it. It's over here, this one, 10594. Summation y, I'm having it. A, I'm having it. B, I'm having it. Summation xy, I'm having it over here, right? So it means I'm having all the values. And what is n? N also I'm having it. So I'll just input the values of all these. And what do I get? Standard error, 0.21995. Okay. You might be getting some different answers. Slight error means calculation errors here and there you might be have, or even in this it might be there. But don't look at the calculations part. Look at the logic part and the steps part. Steps are very important for you, right? So now you have got standard error. What was the question next? Compute the standard error of estimate. So that is done. Find the approximate prediction interval for the dependent variable y when x equals to 44. Now, once I get this line, what I have to do, just put x equals to 44 in this line, and then I'll get y. So what is it? X equals to 44, y equals to what? A is what? 3.64 plus b is what? 0.73 into x is what? 44. I'll input this value and I'll get y. So that was asked. See this. When x equals to 44 with 95% confidence interval. Now remember this. What is it done over here? You will say, what is all this 95% confidence intervals here? It means that I'll first find out y. Okay, I know the exact answer of y, 35.93. Okay, but what are we dealing in? We are dealing in statistics. In statistics, always remember, this is far, I mean, the calculations which we are using are, we have exact numbers, but in practical life, we don't have exact numbers. We do the survey and then get to the value. So when I do the survey, then the person sitting on as my boss or my senior, he won't be interested in this exact answer, this 35.93. He'll be interested in which range will this y lie. Okay, so in which range will this y lie? How do I know this? Okay, for that comes the new term called as confidence interval. What is confidence interval for 95% here? Yesterday we had seen that 68 is 1, 95 is 2, 99 is 3. That's psi, right? Standard deviation. So you can refer to yesterday's lecture then. So with 95% confidence, deviation equals to 2 into standard error, right? 2. And 95 is 2, 99 is 3. So again multiply 2 into standard error, I have got it. That is 0.21. So multiply that, you will get 0.43. Okay. So now what I've got is 95% confidence. I've got the standard error. Now what does it mean? When I get the standard error and I'm having this value of y, what do I do is I'll plus and minus, add and subtract this 0.439 from this 35.93, plus and minus both. So when I plus, what do I get? 36.38. When I minus, what do I get? 35.49. See this, 93 and 49. Okay. So what have I got? I've got this range that 36, this value of y will lie in any case between 36.38 and 35.49. That is the meaning of this. That's why I've got this range. But then you'll say, what is this 95%? What is this 99%? So remember this. There are three ranges used universally. What are the three ranges? 68%, 95%, and 99%. 99% means the chances of your answer means it will be 3 psi over there. If I take 3 psi, the number will be more. So the chances of y lying within this range means if I take the 3 psi over there, then the answer will be something different. Then the chances of y lying in this range are 99% chances. See here, what did I say earlier? Your boss won't be interested in the exact answer. He'll be interested in the range. So the chances, if I take 3 deviations, means 99% confidence, then the chances of that lying between that range is 99%. Here in 95%, the chances of this answer y lying between this range is what? It is 95%, right? 36.38 to means 35.49 to 36.38. In this range, y will lie with a 95% confidence. Now, if I take a single psi, only one psi, means 68% confidence, then the answer will be different. Because then what is the standard error? 0.21. So 35.93 plus 0.21 and minus 0.1. So I'm going more narrower now. If as and when I get more narrower, the chances of any answer fitting in that range become lesser. That's why my confidence interval becomes less. It has become 65%. When I take 2 psi, my confidence interval has confidence level has become 95%. When I take 3 psi, means standard error, then my confidence interval has become 99%, right? So remember always, and this 68, 95, 99 rule means As I go, if I want more confidence, I'll have to take more standard error. So what is standard error now? Okay, those who have followed my earlier lectures, they'll definitely know what is standard error. Standard error means what? Suppose if, let's say, what are we doing in statistics actually? Remember, what do we do in statistics? In statistics, what do we do exactly is, we take some sample. Suppose, let's say you have to survey 1000 people. Population is 1000 of a town, of a village, let's say. You have to survey them, but you can't survey them because you have lesser time or lesser cost. Then what do? Well, you take roughly 50 students, 50 guys from that village, and find the all the mean, mode, median, everything on those 50 guys. Okay. Once you find the 50 guys mean, median, mode, and then what you do, you apply it to the whole population, means whole 1000. So what are we doing? We are taking the mean, mode, median, or any statistic from those 50 guys only and applying it to the whole population. So if I am doing this, then the question of standard error comes. Why? Let's say, suppose if this standard error, this population mean, let's say 1 to 1000, there are 1000 guys. If the average salary within that village or average income within that village is, let's say 50 rupees, or let's say per day income is 100 rupees, and using the survey of these 50 guys, right? I'm doing the survey of these 50 guys. If I get the average as rupees 40, average income. But what is the average population income? 50. What have I got with this 50 guys? 40. So what is the difference? The difference is rupees 10. Why this difference has come? This difference has come because I have not surveyed the whole population. I have surveyed the 50 guys only, right? So this error of sample 40 and the population 50, this difference is the standard error. Always remember this. Okay. So that is the meaning. Okay. So moving on now, you've got the whole case study. Only this case study is asked for 5 marks. Always remember. Means what is required in this? Nothing. Only this table. X, y square, XY. Total done. Put these formulas. These formulas are also one only. 1, 2, 3. Same formula. Right? Y equals to a plus bx. This also I told you how to find out b. Covariance of xy upon variance of x. Then put this b in this y, this equation. Just put summation and y square. Y square minus ay, a summation y minus b summation xy. The whole upon n minus 2. Right? Put it over here and you'll find the value of this standard error. So A you have got by inputting x bar, y bar. B you have got, standard error you have got. So all the marks are yours in your pocket. It's so simple. Okay. So just I told you I'll show you the slide. So this is a slide. Remember the variance for population and variance for sample. These are the two separate formulae. Okay. Variance for population is xi, means each element of x minus x bar, the whole square, and summation, the whole upon n minus 1. N is the sample size. Okay. Then variance of population is xi minus mu. Mu is against here. Some books write this as x bar only. They can write it, not a problem. Why? Because mu is what? Mean, population mean. What is x bar? Sample mean. So mean only. Some books write this x bar only, but it's proper to write, show this as a population mean, and this is a sample mean. Okay, that's why x bar is written over here and mu is written over here. Okay, so done with this, and once done, you can definitely work. You can find out the solutions. Okay, so we'll stop here, guys.